Now this is the second part of the sentiment analysis presentation. As I said in the first part of the presentation, we're going to look at how we can rely less on people and use some semi-supervised methods to build lexicons. The usage of semi-supervised methods based on the fact that we can't label all words. Most of the time we don't have the time, we don't have the resources to perform all this labeling. So what we can do is we are going to start from a set of seed words that we are sure defining the two extremes that we want to have. For example, if you want to classify words into positive and negative, you may start with the words like good for positive and bad for negatives. Because these two words are surely positive for good and absolutely negative for bad. Now next, after we have those seed words, we're going to find ways to label the other words based on the similarities with the seed words. Okay, so if a word is very similar to good, you might say that, okay, probably the word is also positive. If another word is very similar to bad, and then you can say that, I think this word is negative. So we are going to use the seed words to start the process, and then we're going to use the similarities to label all the other words that we have in documents. There are two approaches, two categories of approaches, which is the first is called axis-based, and the other is called graph-based. We're going to look at these two approaches next. Semantic Axis is one of the methods in the axis-based category. So we start this method by choosing the seed words by hand. Notice here that if you have a different domain, you might want to consider different seeds of words. Even though it's the same category, positive and negative, some words are more likely to describe something positive in one domain than the other domain. So for example, in the financial domain, you may think about profit as something that will be very descriptive of positivity in those documents. Okay, and then so it is important to choose the appropriate seeds because these seeds will be the starting points from which you are going to label all the other words. If your seed words are not strong enough to distinguish between positive and negative, then the result of labeling the other words would also be bad, I would say, because your initial seeds cannot distinguish between positive and negative. So the result, when you label all the other words, the result will become bad as well. Okay. So first, you choose the seed words. And then the second, you obtain word embedding for each seed word. So you can use, for example, word2vec to get the vector representation of each word in the seed word set. Now that we have the word embedding for every seed word that we have, we can find the centroids of positive seed words and the centroids for negative seed words. Centroids here simply mean you find the mean or average of all the vectors in the positive seed words and all the vectors for the negative seed words. Let's take an example here. So you suppose you have 3 positive words, and each of this arrow is the embedding vector for each of those positive seed words. And then you have also 3 negative seed words, which is represented each by an arrow as the vector of the word embedding of each word. Now, centroid simply means you try to find, not try, I mean, you really find the average of this embeddings. So you simply take the average of these 3 dots. So you're averaging, let's say, on the x-axis, and then you average them in the y-axis. I made this example as simple as possible, such that when you take the average of these 3 dots here and 3 dots there, the result would look like this, right? So the blue dot is the centroid of the positive seed words, and this red dot is the centroid of the negative seed words. Now, semantic axis simply means that we are subtracting the vector of the positive centroid, this blue arrow here, minus the vector of the centroid of the negative seed word. So the blue arrow here minus the red arrow. So this black dashed arrow is the semantic axis for this example. Okay. And by the way, if I said the wrong name for the color, don't be confused, because I think I've told you that I'm partially colorblind, so I get mixed up between colors. But I'm sure this slide contains only blue and red and black colors. So yeah, don't be confused if you think there's I mentioned something that the name of the color, but you see in your screen it looks different. Well, if you're not colorblind, then you are right. Okay. Now, how can we use that semantic axis to infer the other words, whether they are positive or negative? Well, this is how to use it. We are going to calculate the score for all the other words that are not seed words using this formula. Recall that you have seen this before. This is the formula for cosine similarity, right? So let's say you have the word W. This word W is not a seed word, okay? So it is not a seed word, and you're going to find out, is this word W positive or negative? So what you're doing is you compute the cosine similarity between the embedding of the word W and the vector of the semantic axis vector, this black dash over here. So you compute the similarity between the embedding of word W and the semantic axis. And this score will tell you how positive the word is. The higher the score is, it means that the word is closer to positive sentiment. If we look at this graphically, this black arrow is our semantic axis. Any vector that exactly going through this direction will have a cosine similarity of 1. Any vector that is exactly perpendicular to this vector, which means going there, will have cosine similarity of 0. So now it means that any word with the embedding that falls into this area will have a positive cosine similarity. And then any words that fall into this area will have a negative cosine similarity with the semantic axis. Now, using this 0 as the threshold, you might say that anything with positive score can be inferred as positive word, and anything with negative cosine similarity can be inferred as negative words. You may use such kind of rule to conclude. And then by using the cosine similarity, you can also have the score whether the word is positive with 0.91 or positive with just 0.005. So of course you can say the word with similarity 0.91 is more likely to be actually really positive compared to the other word with the similarity of 0.05. Okay, so that is how the semantic axis method works. The previous method, sentiment axis, is called an axis-based method because the emphasis is on creating that semantic axis. Remember the dashed black arrow? So that is the focus of that method. Now here in this method, it is called a graph-based method because the emphasis of this method is in the graph. We're going to look at an algorithm which is called SENTPROP algorithm, sentiment propagation algorithm. So the very first step is defining or drawing a graph. To draw a graph, the first thing that we need to do is obtain the word embedding for each word. So each word must be represented in a vector. And then we compute the cosine similarity between one word and all the other words that we have in the vocabulary. And then the next thing we do is that we are connecting each word to the nearest k neighbors. How do we know if two words are near or far or anything? We are using the cosine similarity. So remember that you compute the cosine similarity between one word and all the other words, and then you pick the top k words that has the highest cosine similarity with this current word. Okay, so in this example, I think the k equals 2. So for example, the word love has the highest cosine similarity with the word idolize and adore. So that's why the word love is connected only to these two words and not to the others. So that's how you construct this graph. Okay, connect each word with the k highest cosine similarity. And then next, you define a set of seed words. In this example, I think the seed words are love and hate. So love for the positive word and then hate for the negative word. Now starting from each of those seed words, you perform a random walk. So random walk simply means that, let's say you're starting at this place, starting at the word love. And then you throw a random number, and then you pick whether you're going to the word idolize or you're going to the word adore based on the random number that you see, and also based on the cosine similarity between love and idolize and love and adore. Okay, so the path with the higher cosine similarity, let's say love and adore has a higher cosine similarity, it means that it has a higher probability to be chosen when you randomly walk from love. And then you keep going. So from adore, again, you throw a random number to see where you're going. Then suppose you're going to the word appreciate, and then you just keep doing this, okay? And then each word that you visit when you're starting from this word love will receive a positive score. Why a positive score? Well, because you reach that word by starting from the word love, which is positive. So each word that you visit when you start from the word love will receive a positive score. However, the score is not equal. The score depends on the probability of reaching that word, starting from the word love. So of course, the word like, which is farther than adore, for example, will receive a smaller positive score because it is farther from the word love, such that the probability of we are ended up at this word when we start from the word love is smaller than we ended up at the word adore. Sorry, not ended up. We visit the word adore when we start from the word love. And then same thing happen when you start from the word hate. You're starting from the word hate, and then you just perform random walk. Each word that has been visited by this negative path will receive a negative score. Again, this negative score is proportional to the probability of that word being visited when you start from the word hate. And then you do this a lot of times. So this is kind of a simulation. So you run this simulation a lot of time until finally you can get the average of the total of positive and negative score that a word receives. So the result would look something like this. So you will see that the word idolize, adore, and appreciate, they are more positive than like. Okay, and then these words loathe, abhor, dislike, and despise, they are more negative than disapprove or notice, uncover, find, and so on. So based on the positive and negative score that is obtained by the random walk, you can get the average of either positive or negative score for all the other words. Okay. So to summarize this method, the idea is you have the seed words like love and hate. You perform random walk to propagate the score, and then you run this several times, a lot of times, I mean, and then you take the average of the score that is received by all the other words. And that score will reflect the positivity or the negativity of those words. Furthermore, we can also use fully supervised learning to perform sentiment analysis. If you recall what I said before about we can't label all sentences or all words that we have because we simply don't have that much time to do that, you may wonder then how can we do supervised learning? Because supervised learning means that you need to have a training data set, and then each data in that data set should be fully labeled. Now, the idea here is that it's not that us or human or people labeling each of the sentences or words, but we take the signals from somewhere else. In the case of customer reviews, we can take this supervision signals from the rating of the reviews. The assumption here is that if we have the reviews with good or high ratings, it means that we believe positive words are more likely to occur in that kind of reviews. On the other hand, we believe that negative words are likely to occur in the reviews with bad ratings. So you can see here that that assumption is pretty reasonable. It might not always be correct 100% all the time, but it is quite reasonable. You see that in this review, you can see the word wonderful, hilarious, I would recommend, fantastic here. While in the bad review, you can see the word like worst, and then disappointed, and then here you can say you can see the impossible. So those kind of negative words are more likely to appear in the review with negative rating. And by the way, as I was reading this example of bad review here, I'm going to try and stop being deceived by eye-catching titles. I so wanted to like this book and was so disappointed by it. It kind of reminds me of this book. This book is called Bitter Orange, and then it has a very good review, I think. And then look at the cover of the book. Isn't it amazing? It looks very beautiful. So I'm very enthusiastic to start reading this book. It says that this book is a psychological thriller, but then for me, it is very disappointing. Like I kept hanging on reading this book page by page with the hope that at the end I would find something exciting. But then at the end, everything just ended up flatly. It's just flat. Nothing happens. Like, am I the one who is weird, or are those reviewers weird? Like, I don't get this book. Anyway, let's get back to our topic in sentiment analysis. Now, what can you do with the star ratings? Well, one of the interesting things that you can do is finding out the distribution of a word over the star ratings. So you want to see what is the distribution of this word to appear across all the rating score. Let's take a look at the word disappointing in this graph. If we look at the distribution from the rating 1, the worst, up to rating 10, you can see that it is very improbable to see this word appearing in a review that is rated 10. It is the most probable to appear at the reviews with rating 3, 4, and 5. Okay, and this result kind of makes sense. If you give something like a product or a movie with the best possible rating, it is not likely that you're going to say disappointing in the review, right? However, it is also interesting for me to see that if the rating is very bad, like 1, the probability of finding the word disappointing is not the highest, actually. Now, why is this the case? Well, to find out, we really need to look at the raw documents. But my guess is that probably if you are very disappointed with something, like you want to say it is terrible, super bad, like super, super, super bad, then you will not really use the word disappointing. You will use another word that is stronger to express how you really dislike this thing, right? So that's my guess. Now, let's see how we can get this kind of scores. By the way, this kind of score is called Potts score. Okay. So first, we try to compute what is the probability of a word appearing in a particular rating. So here, let's say I'm going to find out what is the probability of the word disappointing to appear given that the review has the rating 1. So we can count how many times the word, so W here is, let's say, disappointing, how many times disappointing appears in the review with rating 1 divided by all the words in the review with rating 1. So that becomes the probability of, given that we know the review is rated 1, what is the probability we will see the word disappointing? And then next, to get the Potts score, we divide the probability of seeing the word in that class divided by the sum of probability of seeing that word in all classes. So the Potts score for disappointing at the rating 1 is obtained by dividing the probability of disappointing given that the review is rated 1 by probability of disappointing given that the review is rated 1 plus given the review is rated 2 plus all the way given the review is rated 10. So the Potts score shows that how likely that this disappointing word appears in the rating 1 compared to its appearance in all rating. Okay, so by doing this computation, we may compute the Potts score for each word correspond to each rating. Now, this is what I said before, that disappointing is not a very strongly bad words. So let's say if it is terrible, and then you can see the curve looks like this. It is very likely to appear when the rating is super bad, and then it just goes down all the way. Same thing on the other extreme is the word excellent. For example, it just goes up But the word good is kind of appearing in the middle, like you say something is good, it's just, okay, it's good, but it's not very special, either especially good or especially bad. Usually we will use another word that is stronger, for example, great, to express that something is extraordinarily good. We can also look at another type of words. For example, here absolutely is used in the extreme, both extremely bad or extremely good. And this word absolutely kind of rarely appears in the middle, right? Because if something is just so-so, then you will not say absolutely. You say it is absolutely good, absolutely stunning, or absolutely terrible. And then this kind of words like somewhat, fairly, and pretty, usually this kind of words is used to describe something that is just so-so, like fairly good, just so-so, not very good, not very bad either. So this kind of results can be interesting, depends on your purpose in doing the sentiment analysis, but this is shown um, to say that the distribution of words across all the ratings can give you some insights about how people use some words in the documents. Now, finally, I'm going to make some comments here. So first of all is that this presentation does not cover all the possible methods or approaches that you can use to perform sentiment analysis. There are still a lot of other approaches out there that you can see, you can think about, you can use to perform this sentiment analysis. So it's still many approaches out there. Like, for example, we have seen this sentiment analysis when we talk about naive Bayes, when we talk about logistic regressions. So there are still a lot of other possibilities. So here I would like to make the comment again about being careful when you choose a lexicon and then apply it to the documents that you're analyzing, because that lexicon might be trained or created based on different domain. So for example, let's take the word sweet. If the lexicon is trained on the review about desserts or recipes about desserts like carrot cake, the word sweet might mean positive. Also in general, the word sweet is positive, like a sweet person. But if you take that lexicon directly and then apply it to your review, the result might be misleading if the context is very different. Let's say your review is about a restaurant whose specialty is chicken kanji. Chicken kanji is supposed to be savory. It is not supposed to be sweet. So if a lot of reviewers say that the chicken kanji is sweet in that restaurant, if you just use the lexicon, you might conclude that the reviewer says positive things about the kanji. But if you think about it, actually they mean something negative, because chicken kanji shouldn't be sweet, right? Yeah. I definitely wouldn't want to eat any chicken kanji that is sweet, right? And by the way, I also would not want to eat a bowl of chicken kanji where everything is just mixed up in that bowl. I would prefer everything, all the toppings just sits beautifully on top of the kanji. And then I eat everything part by part so I can taste everything distinctly. Okay, so that's about chicken kanji, and let's move on. The other thing I like to say is about when we're analyzing a sentence, sometimes we need to know what is something about, especially if the sentence is long like this. So it is not unusual that you see a customer review in which a sentence contains a lot of words. These kinds of sentences should actually be, cut into several sentences. But people who write reviews, sometimes they don't put period between the words. They don't even put commas, so that you just consider all these words as a sentence. Okay, so I take this sentence from my paper, and then if you think that I'm very proud with my papers, well, firstly, yes, I am, because it really takes a lot of time, thoughts, and efforts, and just everything to publish a paper, really, trust me. And then secondly, the reason is that there's some plus points if we can include our research in our teaching. It will be a good point for the university and for the institution. So anyway, let's get back to this long sentence. So I'd like to know, for example, I see the adjective here, cheap, but I want to know what is cheap here. Is it the device, the screen, the construction, or what? So I'm using the combination of part of speech tagging, dependency tree, and then based on this dependency tree, I try to infer that this adjective is related to that noun by looking at the parent-child relationship. Okay, but then you can see here this approach is not perfect, because you see I identify fantastic price, although actually it should be fantastic screen instead of fantastic price. So you can see here that almost all approaches, they have kind of some inaccuracies, because sentences are really hard to be exact. Any person can write his or her own sentence with the variations, with all the things that shouldn't be there, but exist in the sentence, or the other way, that things that exist in the sentence but shouldn't be there. So it's just difficult to have a method with 100% accuracy. In the level of the word, when we're doing sentiment analysis, we also need to be careful or pay attention to the existence of negation words. For example, here the sentence says, the touchpad to move the cursor is not very good when I push it to click on a site. So again, the approach that I used was using the dependency tree, such that first I can detect which adjective is connected to which noun. So here I know that the word good is related to the touchpad. And then I can see that the negation word not will change the relationship between good and pad. Okay, so dependency tree is one of the ways that I believe is one of the most accurate, I will say, to see whether the negation negates the relationship that we're looking at. In this case, the relationship I'm looking at is good and bad, and then based on the tree, I can see that the word not negates that relation. If you just look at the dependency, then you might see that this word not is between good and cursor, and then you might get the wrong idea that this sentence is saying about the cursor is not very good. So you can see that I really like dependency tree because it shows the relation between words. Even though the words are separated by a lot of words in between, dependency tree most of the time can show the correct relationship. Of course, as any of the text mining tools that we've seen, there is no tools that is 100% accurate when it is applied to any kind of sentence. And then I also like to address the problem with aggregating sentiments. So sometimes when we would like to know the sentiment of a sentence, we aggregate or averaging the sentiment from each word in that sentence. When we have a paragraph or a review, sometimes people also use the approach of aggregating or averaging the sentiment from each sentence in the review. So something like this, you find the sentiment of each sentence and then take the average sentiment. But notice here that it might be inaccurate because there are some sentences like amazing. It has only one word and amazing is mostly positive in most contexts. Brilliant is also mostly positive, so it might make the conclusion of the entire review inaccurate. But then how to address this kind of problem? How would you know if that word amazing is actually positive or is it a sarcasm? Well, I have to admit that it is a very challenging problem because here you cannot use dependency tree because dependency tree only works for the relation between words in a sentence. Here the relation is across sentences. You need to see that this amazing follows the story about something else in which this reviewer just feeling that he is out of luck, he or she is out of luck because his laptop is broken, but there's no warranty support. Okay, so he or she said amazing, but it is sarcasm. But to detect that kind of sarcasm, you have to go back to the previous sentence. Now, it's also not clear how many sentences you need to go before that sentence or after that sentence to get the explanation. Another example is that if you just look at the sentence, total incompetence. If you want to know what or who is incompetent, you cannot get the answer just by reading this single sentence. You need to go back to the previous sentence, or you might need to go to the next sentence. So again, this is kind of a difficult problem, but I like to address this so you are aware that there are some situations that make sentiment analysis and also in text mining in general becomes more complicated. So that's the end of my presentation on sentiment analysis. I hope the methods, the tools, lexicons, and then some comments from me will be useful when someday you're performing sentiment analysis. Thank you.